Okay, when you were in Applied, we spent some time solving systems of equations. There were three methods to do. The first method was a graphing method in which you graph it and find the intersection points. The second method was to do the adding of the two together. And then the third method was a substitution method. Now we primarily did that for just lines. So there was either a solution in which you had one solution, no solution in which you had parallel lines, or infinite number solutions in which the lines were exactly the same. But now we're going to add in one step to this, and that is, not are we just looking at just linear equations, we're also going to look at quadratic equations. So when a quadratic equation occurs, let's have a look and see what are all the possibilities as to how many intersection points I can have. Well, very similar to, so I'm talking about quadratic equation with a linear equation, so a quadratic, a parabola, and a line. So I can have no solution, right? I can have one solution in which it just touches at one coordinate, or I can have a possibility of two solutions. So what we're going to do is we're going to use those three methods that we learned for linear equations, and we're going to apply it to quadratic equations so that we can solve and find out what our coordinates are where two equations intersect. Okay? I'm not going to go through the graphing part. That's just strictly Desmos, and you can do that on your own. Just graph them and find the intersection coordinates. So the first equation is this. Solve the following systems of equations graphically. I'm not going to do graphically, I'll do it algebraically now. So here's what I have. I have y is equal to negative 3x squared plus 2x add 4. Okay, so what did I do with that first equation? What was the first thing that I did? Isolated y. I'm going to isolate y in the second one as well. So to do that, I've got to go minus x minus 2. Everybody follow that so far? So basically all I've done is arrange the equations. I moved everything to the right side and left the y equals on the left side. Okay? So now, if y is equal to minus 3x squared plus 2x plus 4, and y is equal to negative x subtract 2, I can just let those two equations equal each other. This is basically what we did with substitution method. Alright? We isolated one of the variables. In this case, I've isolated both of them. So I'm going to let this equal, so I'm going to go minus 3x squared minus 3x squared plus 2x plus 4 is equal to minus x minus 2. Now for every quadratic to this point, what have we done? Made it equal to 0. So I'm going to add this all to that side. So 3x squared. Subtract 2x from that is minus 3x. Subtract 4 is minus 6. Okay. So again, because I have an equal sign, I want to solve this. So the first thing I want to do when I'm looking at it is, can I factor? Is there a greatest common factor in this one? 3. So let's divide everything by 3. So I'm left with 0 is equal to x squared minus x minus 2. Is that factorable? What are the factors of x squared?
X and x. 2
X and
minus
x.
1.
2 plus minus 1.
No, negative 1 plus 2.
Yeah, sorry. Just switch those? What you're saying?
Yeah, negative 2.
Okay. So therefore, what does x equal?
2 and negative 1.
2 and negative 1. So not anything new to us. We've done this already. We've done this over and over and over and over again, working with quadratics. All right? So I have the x value of the coordinates where they meet. So I need to find the y value of the coordinate. So 2 and, so I put 2 in this equation here. I always use the smaller one, the easier one. Minus 2 subtract 2. minus 1 in there, so that'd be plus 1, subtract 2, negative 1. There's my point of intersection for those two. Questions? Okay. All stuff that we have done multiple times in applied and pre-calculus. Going to solve for the quadratic. All right, now, what happens now? How many possible solutions do I have if I have two quadratic equations? Okay, one could be just touching right here, right? What else? Possible for two?
Sure.
Yeah. I could have 0.
Did you have to? Or infinite?
Is that it? If they're the same, I could have an infinite amount. Yes. Yeah, it's possible. Not likely to happen, but it is possible. If you had the exact same graph twice, sure. Yeah, so there's your possible solution, 0, 1, 2, and then I guess you could have an infinite amount too. Okay, so let's look, again, algebraically, how do I want to solve this? So I've got, looking at page 335, so I'm going to go y is equal to, I'm actually going to do this one a little different than the last one. 3x squared minus 12x add 16. Y is equal to minus 4x squared plus 16x minus 12. Okay, so I've done that, right? Okay, so when we did the sum one, what was the one thing that I needed to do? What did I need to match up? You guys remember? Okay.
Like the substitution.
No, not substitution, the other one. Where I added them together when they were stacked. What did I have to make sure happened? Same what, sorry, Mary? Okay, yeah. You're on the right track. Okay, so what I'm going to do here is, what is it that I need to get rid of in these two equations first? Because right now I have, how many variables in, let's say, look at the top equation. How many variables do I have there? I have 3, right? I have a y, I have x squared, and x. Okay? So what I want to do is I want to eliminate one of the variables to begin with. So the easiest one to do is the y. So I'm going to change all of my signs here by multiplying everything by -1 in this second one. So it's going to look like this. Negative y, that's a plus 4x. That's going to be a subtract, and that's going to be a plus 12. Okay? So I changed all of the signs of the second equation. And now what am I going to do? Add them. I'm going to add them, because if I add those, they cancel, right? Alright? So 3x squared and 4x squared, 7x squared. Minus 12 minus 16, minus 28x. 16 and 12 is 28. So, yeah. So what have I gotten rid of? What did I need to get rid of? My y. Now I have a quadratic equation equal to 0. So how many methods do I know how to solve this? 3, 4. Right? If you consider graphing as one of them, I know of 3 or 4. So let's just see if it's factorable first. That's the easiest. Is there a greatest common factor here I can divide by? 7. So 0 equals x squared minus 4x plus 4. Agreed? Yeah? Okay. What is it? X minus 2, X minus 2. X is therefore equal to 2. All right? Yeah, but I don't have to put it twice. What is this telling me? Okay, I want you to think about this for a second. I've only found one value for X. So I've only got one coordinate, right? So I have two quadratic equations. One solution. One intersection point. Where is the most likely spot that that intersection point occurs? On the graph itself. Most likely spot would be at what? What do we call that? At the vertex. Okay? Now it is possible. It is possible that you could have one in which it does touch like that. It is possible. I don't think we're going to work with it, but for that. So, I've got x equals 2. I'm going to put it into this top equation. 2 squared is 4. 4 times 3 is 12. 12 subtract 24. Negative 12. Negative 12 add 16. My intersection point is 2 and 4. Okay? Now, just for the heck of it, not required, just for the heck of it, let's take the first equation. The first equation was what? 3x squared minus 12x add 16. All right, here's what I want to do. I want to change the form to vertex form, just cuz. So how do I have to do that again? What's that process called? Completing the square. Right. So what's the first step in completing the square?
Take out the A value.
Not yet. What do you do before that? Brackets, that's right. And then, Rory? Take out the A value. So I have 3x squared minus 6x plus a blank. Add 16, subtract 3 times that blank. Whatever the A is on the outside, I have to multiply it by that on the over here and subtract it. Okay, what goes in that blank? 3 squared, half of 6 squared, which is 9, right? So y is equal to 3x subtract 3 squared, 16 subtract 27, negative 11. Huh, I just contradicted exactly what I just said. Oh, it's supposed to be the vertex. It didn't. It wasn't. Okay? The vertex for this graph was 3 and negative 11. But my solution where they touch was 2 and 4. So, I completely blew that one. Let's have a look at it. Okay, I need help again. I need the two equations. So y equals 3x squared. Yeah. Plus.
Oh no. Negative 12x plus 16.
12x plus 16.
And then
Graph.
negative 4x.
Just a second. Y equals a negative what?
4x squared.
Okay, 4x squared. Yeah.
Plus 16.
Plus 16x subtract 12. What's going on here? Are you sure you gave me the right equations?
Why is it? Move that one over. It should be negative. Oh no, never mind. I forgot to. I didn't.
Negative plus.
It did time it by negative 1, so I didn't understand the negative 1 on this other side.
So this equation is not right?
No, it's not. Because you multiplied it by negative 1.
Let's do this differently. Let's do this differently. Let's delete all the graphs. Okay?
Here, take my book.
No, I want you to read me the actual y.
Y minus
Like, read exactly as it is in the book. Okay, so y
minus
minus
3x squared
3x squared, yeah,
plus 12x
plus 12x, yeah,
equals 16.
equals 16.
And then
Yeah, yeah,
y plus 4x squared
plus 4x squared, yeah,
minus 16x
minus 16x, yeah,
equals minus 12.
plus 12.
I was right.
You're right. Okay, what else happened there? I feel like I was right. Happened at the vertex. So where was our error made? We had to have done something wrong in here. Did we? Yes. I made a crucial error. Where's the error?
Should be 4,
Where?
6.
Yes. What was the error here?
You divided 12 wrong.
I divided incorrectly.
Oh my
Wow,
gosh.
I'm nervous.
You make fun of our math.
Make fun of your math, never. It shows you that you can make errors though. Alright? It's alright. Errors happen, we learn from them. Okay, so there should be a 4 there, right? 4 there.
2 squared.
2 squared.
And then 4.
And then 4 here, so now I've got 3. X minus 2 squared
Minus 4.
plus
Plus
4. What's the vertex? Oh, how easy we make mistakes. So now I'm not a liar anymore. It's always going to be vertex. Alright? So, look at our graphs. Where did they intersect? 2 and 4. The vertex for both those graphs. Okay? That's why we check things over. And that's why you also can check those things over. Alright? You do the algebra, graph it. Find out if you got it right. That's okay. Alright? So that's a quadratic with a quadratic. And then all the next thing is just actually writing out the equations yourself. Okay, so that'll be part of it. That'll be the hard part as we go through 8.1. Okay? Alright, I'm just going to shut this off.